that. Boom shakalaka. Okay, here we go. I'm going to teach you quite a few ways. And since the ladies aren't here today, we can use red. Yay! Alright, so the one thing, the first thing I want to teach you is, remember we were doing chain rule, right? And we can actually, remember at the beginning of the year I said, ooh, we can do this in a quotient rule, which is really hard, or we can just move it to the top, right? So guess what? We could move this to the top. And that would be y is equal to 2 times, right? X squared minus 3 to the negative 1. Does that make sense? Okay. Now, when I find y prime, now I take this times the outside, that's the chain rule, right? So that would be negative 2, subtract 1 from it, times x squared minus 3 to the negative 2. Does that make sense? Okay. And then times, remember we got to do the inside now.
Yes.
So then we have the derivative of that, and that would be 2x. Does that make sense?
Yes.
Okay. And now we collect our like terms. Okay. So we would collect our like terms, multiply these, we get y prime is equal to negative 4x, right? 2 times 2 is 4. All over, because this is, bring it down, right? And make it positive. So all over x squared minus 3 squared. Let's see if that's even right, first of all. So that'd be what, number 1?
Yeah.
So is that correct?
No.
4x negative over x squared minus 6. So what they did is they took it out of its polynomial. So they said, hey, we want this, but we want this out of its polynomial. So they want this as y prime is equal to, and they put the negative out in front, 4x, right? And then they did this squared, which is x to the 4th, and this squared, which is plus 9, and this times this times this is 2 times 3 is negative 6, so negative 6x squared. So this should look more like what they have. Is that true? X to the 4th
Yeah.
minus 6x squared plus 9. There you go. It's exact. Now, I didn't use the quotient rule, did I? I used chain rule.
Yeah.
Now, how would I do this using the quotient rule? Again, if I'm starting with this function, y is equal to 2 over x squared minus 3, right? If I'm starting with that function, what I want to do is I want to look at 2 different derivatives. First, what is the derivative of this? 0. Okay? What is the derivative of this? 2x. Right? Okay? So that's the derivative of the top and the bottom, right? And so, you have f of x, f prime of x, g of x, g prime of x. Does that make sense? Should we write that next to it? So this is equal to f of x, this is equal to f prime of x, this is equal to g of x, this is equal to g prime of x. And then you just have to remember the order in which you put them in. Okay? So y prime is equal to the prime of, now the book shows it a different way. I don't do it the book way, I do it my way because my way's better. No, it's true. Okay, so I like f prime of x, g of x. They'll do it as g prime of x, f of x. Okay? or they do it backwards, either g of f of prime. One of them goes first all the time. That makes it even more confusing to me. So the way I look at it is, one of them is prime. So the first one, top, you find the derivative of the top times the bottom, minus the top times the derivative of the bottom. Does that make sense? And then all over the bottom squared. Okay? So, right away, I'm going to take the derivative of the top, that is 0, right? Times the bottom, which is x squared minus 3, minus the top, which is 2, right? Times the bottom, the derivative of the bottom, which is 2x, right? All over the bottom, x squared minus 3 squared. Okay? So, when we look at this one, this is 0, cancels out. This is negative 4x, right? All over x squared minus 3 squared equals y prime. So, for some people, this is good enough. And then for our book, they wanted us to take it that next step, right? So the next step was that negative outside, the 4x up top. Then we're going to take this and stretch it out. In other words, we're doing x squared minus 3 times x squared minus 3 and doing the clamshell.
Yeah.
Okay? Which is x to the 4th. There's a quick way of doing perfect squares. It's this squared plus this squared plus 9. And this times this times this. Okay? So 2 times negative 3 is negative 6. Negative 6 times x squared is negative 6x squared. And that's how you find your middle function. So that's a trick way of doing that. Alright? And so there you go. The same output, different way. Does that help?
That does actually.
Okay. I am going to go to that meeting real quick.